Welcome to a little bit of lab rat fun networking with Fishstyle. In our last CyberFlood video, which was the first of the series, we just had simply one switch and two CyberFlood interfaces. So when we had the traffic running from the client side 10.101 going to the server side, it was simply that the client side 10.101 would go to its default gateway, which was the Nexus 9K, and the Nexus 9K would just go ahead and see that the server side 10.201 was directly connected. Now, in some situations in proof of concept labs or other types of testing, you might not want to have the clients and the servers. You might want to abstract a layer for whatever reason, which is also a lot, admittedly, of what I do right now. Is I tend to use layer 4 through 7 traffic generators with firewalls, next generation firewalls and other security devices. So I'm trying to actually have like maybe potentially a lot of different subnets, but behind one device, a little bit more realistic that the next generation firewall, which is where the Nexus 9K normally would sit in testing that I'm doing, would have a router or two on one side, a router or two on the other side, or something like that. So it's not uncommon that what you want is you actually want the subnet that is connected to the Nexus 9K to be a subnet that is on the client side, to be a subnet that is different from the origin client subnet. So as you can see in this situation, 10.101 is the client subnet on the CyberFlood, but 10.11 is the subnet that I want to have directly connected on the Nexus 9K. So obviously there's a gap that happens there. I can't just jump from 10.101 subnet over to 10.11 subnet. So I need something there. I need some type of layer 3 device to get me between those two subnets. CyberFlood has a construct called the CyberFlood Virtual Router. So it's just like a virtual router, except with an additional kind of sort of construct that the CyberFlood router that I create there is just directly connected to the client. So I don't really need routing between the client's 10.101 and the CyberFlood virtual router that exists only for them. So, but it's a virtual router, and I might want to do the exact same thing over on the other side. So I might want to have 10.201 but on the Nexus 9K, and then having the CyberFlood in 10.201. And so then I would have the CyberFlood virtual there as well. This is, again, extremely common, especially for what I use layer 4 through 7 traffic generators for and how customers want me to use them and how we test with them. So I'm going to go ahead and explain this. So basically, if you think about it like any kind of regular routing, when the client sends traffic from 10.101 to 10.201, it's going to hit this construct of a virtual router on the CyberFlood. And the virtual router is going to be like, well, I don't know. What do I do with 10.201.1.101? What's the destination? And then it has to do something with it and then pass it on to the Nexus. That's kind of sort of where we want it to happen. We want the answer when the CyberFlood virtual router says, how do I get to 10.201? To be, I want you to go to the Nexus 10.11.01. And then when it wants, we want to know that it goes ahead and it goes over to the CyberFlood. So we're going to need IP addresses. As you can see, the CyberFlood there is 10.21.03. So we're going to need IP addresses. As you see, the CyberFlood on the left needed to know, and we'll have a static route in there that if it wants to get to 10.201.1.101, it's supposed to go to next hop 10.11.01. And then, of course, ARP for that, and getting a MAC address so that it pays attention, picks it up, sends it on. And then also when the Nexus wants to go to 10.201, it needs to know its next hop to get to 10.201. So that's why everyone's going to have an IP address. The CyberFlood virtuals on that subnet between the device under test, the Nexus, and the CyberFlood virtual. The CyberFlood virtual is going to have a 4th octet. Obviously, the Nexus is going to have a 4th octet. Sometimes it gets a little bit confusing to people about the CyberFlood virtual having a 4th octet and also needing to do routers, static routing. Hopefully, this helps with you on that. So what we're going to do is we're going to create a CyberFlood virtual over on the client side. And we're going to also tell it instructions of, hey, if you want to get to 10.201, okay, then what I want you to do is I want you to go to next hop 10.11.0.1, which is going to be, of course, the Nexus in our situation, or normally in my testing, the device under test. And then, of course, on the Nexus, we're going to need static routes that say, hey, if you want to get to 10.201, I want you to go ahead and I want you to go to the CyberFlood. So what we're going to go ahead and do in this video is we're going to go into the existing CyberFlood test that I had before. We're going to add 2 virtual routers. And then we're going to go ahead and check routing, make sure all the statics are set up over on the CyberFlood as well as on the Nexus 9K. Then we're going to run what I would call a trial run. Now, when you run a trial run in CyberFlood, the traffic is going to go across, but only just like, it's like, just try this. Don't send a certain amount of don't have a specific load simulation you're trying to hit, like on the past one, 6 gigabits per second, or a number of simulated users that you're trying to do. Just go ahead and run it. Oh, and by the way, when you run it, save off a pcap. So what I did was after I did the other video, at the end, I just went ahead and showed it to you, and I showed you the live results page, which admittedly can be a little bit overwhelming because there's a lot of information on there when you've never seen it before. So what I went back in after the other video is I went back in, did a trial run, have the pcap downloads for you for that, and then we're going to run a trial run on that. Going to get pcap downloads for you on that as well. And then I'll tie these two together, do a networking with Fish blog, reference these, and then I'll have a link for you to grab the pcaps if you want to go ahead and look and play and see really under the covers the true layer 4 through 7 that's going on. So let's go over, and we're going to go into the CyberFlood. This is my existing test that I had before, CyberFlood Fun. Now, as I told you before, we actually created this in the previous YouTube. I could have gone ahead and just grabbed clients that we already have. We also do have virtual routers that I could go select from because we run a lot of tests. We use a lot of the same like subnets so that we just have some repetition and stuff. But I'm going to go ahead and I'm going to make a virtual router. Now remember, my client subnet is, so I'm going to do it this way. Again, I could have dragged in. So we're going to call it Fun with Fish and Client VR. So this is the client virtual router, the blue thing that I had. And the IP address, if you recall, and this is one of the reasons why I do this, I know the client side is 10.101. So I'm going to make that subnet between the virtual router and the Nexus 9K be something that I can relate to. So instead of 10.101, drop a 0, 10.11. So 10.11.0.3. Now this is going to be a little bit strange for people. Why did you pick .3? Sometimes the device under test is a .1, is a .2, so people aren't necessarily using .3. We just tend to use .3 in our group, so I'm typically used to having my CyberFlood Virtual be a .3. Now, not doing VLANs, I'm not doing anything else. However, this is where I'm going to go ahead and put my static route. Now this says, add static routing, but I can also just go ahead and do this. So static route prefix address. You know what? If you want to go to 10.201.0.0/16, then I want you to go to 10.11.0.1, which is the Nexus 9K. So go ahead and take your little cheat sheet out. Clients are 10.101. The CyberFlood virtual router between the clients and the Nexus 9K is going to be 10.11.0.3. The server side, where the clients are trying to go to, is 10.201, so I've got the static right there. And then if you're trying to go here, go ahead and go to the Nexus 9K. So I'm going to save the profile. Now what's going to go ahead and happen is you'll see this little thing here that says select ports to be routed to. We're going to get back to that. Let's go ahead and do this side. And it's going to be Fun with Fish Server VR. Now remember, the server subnet is 10.201, so I'm going to go ahead and drop the 0, so 10.21.0.3, and that's 24. And then if you want to get to so this is the server side, so if you want to get to the client side, then you need to go to 10.21.0.1. Go ahead and check this, check your diagram, good to go, right? Now, obviously, Spirent's very nice here. They're like, big red thing, select ports to be routed. So what happens, as you can see before, if you recall in the first video, I assigned the client side to a specific port. if I click right here where it says click to select ports to be routed, this is really, really, really simple. I don't have to think too much, so rock with that. And this says client virtual routers, server virtual routers. So when I click over on the client side, it brings me here. This is virtual router assignments. Now I'm going to say cancel here, and I'm going to show you that if I had clicked on the server side, it would have said virtual router assignments. It's just that it would have tabbed me and already opened the tab for server virtual routers. So I like doing this because I can do both at one time. So the client virtual router, so here's the client, the fun with fish, and it's even going to tell me client 101. So if you see this client 101 and this client 101, obviously what I want to do is I want to have the client side virtual router tied to the same port as where my clients are coming in. So there's no routing there. This is just the construct. It's almost like doing a direct cable directly to it, so you're just using code. So then I do the exact same thing. So on the server virtual router, I connect my server virtual router, which we just called Fun with Fish Server VR, and I connect that to 1.2, which is the port off of 168 that is directly connected to my servers. Okay? Update. Simple. Now, before I forget, I'm going to go ahead and I'm going to save as, and this time we're going to say CyberFlood Fun with VRs. And I'm going to save. And before we do anything here, I am also going to go over to my Nexus 9K. I'm going to do a show run interface E111. Now, in the prior video, this was 10.101 because it was the client subnet. It is now 10.11, and it is associated with the client side VR subnet. Show run interface E115. And this is the server side VR. If I do a show run include IP route 10, then you'll see I have two static routes. And that is, hey, if you want to go to the client side, go talk to the CyberFlood VR 10.11.0.3 that can get you there. Oh, and hey, if you get traffic coming in that wants to go to the server side 10.201, go to the CyberFlood VR that will help get you there. Or show IP route static. So we're good. Everything's fat, dumb, and happy. So now let's go ahead and go back over here. Now, before I went ahead and I just did a click. Did all of this bandwidth stuff, did a lot of stuff, brought you to a screen that had tons of information that I love and I geek out on. What I'm going to do instead, and what I did post the other one, is I'm actually going to come up here and I'm going to go right here and I'm going to click trial run. So even though it says bandwidth specification is 6 gig, it's not going to try to do that. This is just going to be a trial run. It's going to go from these clients with this VR to these servers with this VR, with these specifications right here, and with all of these different protocols. And that way, I can get a small sampling, trial run, see did it work, did it not work, am I cabled the wrong way, are my subnets wrong, is everything copacetic before I try to do a bigger run. And so if I do a trial run, it's still going to do the same thing that it did before in the other video, which is to verify the test, divide the load, and update, because it still has to send the instructions just like the other one. So this is still full layer 4 through 7, as you'll be able to see in the pcaps. Okay, so here we are with trial run. So this is the CyberFlood. Oh, I waited too long. It was just like, I don't know how many seconds that was. But anyway, it says trial run right up here. We've got 114 attempted, 114 established, 90 established, closed with no errors, et cetera, et cetera, et cetera. All I really care about is that if I come down here, I got a nice green pie, 100% successful, which means we're good. Everything's fantastic. I can go ahead and start doing whatever test I wanted to. Now, admittedly, sometimes what I'm trying to do is I've tweaked an MSS value or I've tweaked a byte size value. So I actually may want to go ahead and do this. So I'm going to I'm going to download the zip file. So it said download and debugging files. So that's going to go ahead and it's going to download, and it's a zip file. and it's going to have pcaps in there. It's going to have client-side pcaps and server-side pcaps. So let's go ahead and go to my downloads file. So here's the debug.zip, and when I unzip it, I get all of these different pcaps. So these are the 3 client-side pcaps and 3 server-side pcaps. Now, why are there 3? Because of the fact that for a 10 gig interface on the C100, there are actually 3 cores. So you get a pcap of what each and every core was doing, core 0, core 1, core 2. But I'm going to go ahead and I'm going to upload these onto a public environment, and you can go ahead and just have fun and look at these, and let's go into full screen. But if you come up into statistics and you do protocol hierarchy on this, you'll actually see, here we go, okay? So we have UDP, we have Telnet, we have SMTP, we have SMB, we have HTTP, we have FTP, we've got BitTorrent, et cetera, et cetera, et cetera. So this will actually show you all of the different things that are happening, what the percentage breakdown was, and also, again, if you recall correctly, and this is what I want to kind of sort of drive home about a layer 4 through 7 traffic generator versus a normal packet blaster. See all this stuff in here I talked to you about before? These are the windowings, the ACKs, what the MSS is, everything. You're going to see that transposed over into here. So you're going to see all of the different, so if you say that you want to do delayed ACKs or this type of ACK or that type of ACK, or you want to go ahead and send resets instead of fins at the end of a conversation, or you want to send fins instead of resets, that's all going to come in here and get pushed out as a set of instructions. So again, that's it. A lot of different fun. Here you got the TLS and everything. So just lots of different fun. And that's pretty much it. And that is CyberFlood starting in the nutshell. How to do a client, how to do a server, send traffic. Also, how to do a client, how to do a server, 2 VRs, send traffic. Now on the other one, you just do live and you can go through all of that and have fun and set a load profile, or you can go ahead and do what I like doing, which is first do a trial run, see exactly what it is that you're sending, make sure it works, and then go ahead and kick off. Hope you're having a lot of fun with the CyberFlood series. Tons more to come. Got a lot of security stuff coming up too. So anyway, see ya. Have a good one. I'm out.